There's a paradox hiding inside machine learning that most engineers don't discover until they've shipped enough systems to feel the pain firsthand. The models that get replaced the fastest are often the ones that look the best on paper. High accuracy scores can actually create a false sense of security, masking the slow, silent decay happening underneath in the real world. Imagine training on clean, carefully labeled data, hitting 94% accuracy, and shipping to applause. 6 months later, business rules have shifted, user behavior has evolved, and your model is quietly making decisions nobody trusts anymore. The cruel part? It still reports 91% on that original test set, so no alarm ever sounds. You've built a confident system operating on stale assumptions. Here's a mental model that changes how you think about deployed systems. Imagine hiring someone brilliant, but they receive zero feedback after their first day. No corrections, no updates, no learning from mistakes. They just execute with total confidence based on what they knew at onboarding. That's exactly what a deployed ML model is doing. And in a changing world, that's a slow-motion disaster unfolding in production. Unlike software bugs that throw errors and trigger alerts, ML degradation is invisible by default. Prediction confidence slowly erodes, input distributions shift away from training data, and the model keeps returning answers with the same unwavering confidence it had on launch day. This is why monitoring shouldn't just track overall accuracy. It needs to track confidence distributions, input feature drift, and edge case exposure over continuous time windows. The unglamorous work that nobody writes conference papers about is what actually keeps ML systems healthy. Monitoring input distributions, building pipelines that flag out-of-distribution inputs, tracking per-segment confidence trends over time. These aren't research problems, they're engineering discipline problems. The teams winning in production aren't necessarily the ones with the best models at launch. They're the ones who built the best feedback loops after launch. There's a common and costly misallocation of effort in ML teams. Spending months squeezing a marginal accuracy improvement out of a model that was already performing well enough, while investing nothing in mechanisms to detect when it starts degrading in production. That extra percentage point is nearly invisible to users. A complete failure to catch silent model rot absolutely is not. The expected value calculation here strongly favors operational investment over benchmark chasing. The most experienced ML engineers approach their own models with healthy skepticism. They don't treat evaluation as a gate you pass before launch and then forget. They build systems where evaluation is a living, ongoing process, continuously comparing real-world prediction patterns against baseline expectations, automatically surfacing when something drifts beyond acceptable thresholds. Assuming drift isn't pessimism, it's the correct prior given how dynamic production environments actually are. The launch moment is not the finish line, it's closer to the starting gun. Everything that determines whether a machine learning system actually delivers long-term value happens in the operational phase after deployment. If your team can't clearly articulate what your degradation detection looks like in practice today, not theoretically, not in a future roadmap, but right now, that's the most important gap to close before you optimize anything else.